we're going to continue talking through some of these, and I think just when we get into the examples with actual numbers, it starts to make a little more sense. So if you look up here at the example, whatever this number b is, multiplied by or raised to the m over n power, that's really b to the 1 over n power times whatever m is. Okay. And that's probably, you're probably hearing blah, 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 blah. So let me show you kind of what that means as far as like when you get an actual set of numbers. 27 raised to the 2/3 power is the same really as 27 raised to the 1/3 power squared. Okay? Because the squared part came from the 2 up here. The 1/3 was what was left. So if I just take the radical, the 2/3, sorry, not the radical, the power, if I just take that, that's really 1/3 times 2, which is basically how I split it. 1/3 squared. Okay? All right, so you've got 27 to the 2/3 raised to the 2/3 power. And that really is 27 to the 1/3. But 27 to the 1/3, remember, is really the cube root of 27. So it's the cube root of 27 squared. What is the cube root of 27? Well, I'm looking for whatever number multiplies by itself 3 times to give me 27. Okay? Cube root of 27 is 3. So the cube root of 27 is 3, and 3 squared is 9. Okay, let's look at this next one. 25 to the 3/2 power. The bottom tells me, okay, I'm going to take the square root. Square root just means the second root. I'm going to take the square root of 25, and I'm going to raise it to the 3rd power. Okay? And sometimes I don't like their little blanks and stuff. So the square root of 25 raised to the 3rd power. Square root of 25 is whatever number multiplied by itself gives you 25. So what is the square root of 5 times 5? Square root of 5 times 5 is just 5. And 5 to the 3rd is 5 times 5 times 5, which is 125. Okay? All right, let's keep going and just do some more examples, shall we? Okay, this time I'm going to try to remember to move the paper up when my writing starts to get too low. Let's see, I'll write in a red color. All right, 32. The 5 down there at the bottom tells you you're taking the 5th root of this number. So 32. I want the 5th root of 32, and I'm raising whatever that is to the 3rd power. Okay, this one requires a little bit of thinking, but I'm going to go ahead and tell you 2 times 2 times 2 times 2 times 2. 2 to the 5th is 32. So the 5th root of 32 is just 2. And 2 to the 3rd is 2 times 2 times 2. And your answer is 8. Okay? All right, let's do, I'm going to change colors so that you guys can tell which things go with what. All right, we have 4 raised to the 5/2 power. Remember, the bottom tells you what root you're going to take. So this is the square root of 4. Remember, I don't have to bother putting the little 2 out there. The square root of 4 raised to the 5th power. This other one, again, is the bottom of the fraction. Tells me what I'm what root I'm taking. So again, it's the square root of 4. Top part tells me what I'm raising all of that to. Okay, what is the square root of 4? It's 2. So you've got 2 to the 5th. What is the square root of 4? It's 2. And you've got 2 to the 3rd. All right, 2 to the 5th is 2 times 2 times 2 times 2 times 2. So that's what this winds up being after you've done all of this. And then this one winds up being 2 to the 3rd, which is 2 times 2 times 2. Order of operations, remember, you multiply and divide before you add and subtract. So all of this together, 2 times 2 times 2 times 2 times 2 is 32. 2 times 2 times 2 is 8. And so you get 32 minus 8. And your answer is 24. Okay? So really, I'm hoping that you're starting to see that really this is just a practice session with translating what exactly they've given you and what to do with it. Okay? This is a good question. Why can you evaluate an odd root for any radicand, but even roots require non-negative radicands? Because remember, like a negative times a negative is a positive. But times another negative, you get a negative answer, and you run into trouble with negatives on your square roots. So I don't think we'll run into that too much, but just keep that in mind. All right, we're going to start with some homework. Okay, so let's do a few of these together. I'm not going to do them all with you, but we can start practicing. So 10 to the negative 2nd power. Well, I'm going to go back and remind you about the first page. Do you remember when we had 3 to the negative 2 power? It was the same as saying 1 over 3 to the positive squared. So 3 to the negative 2 was the same as this. So 10 to the negative 2 is the same as 1 over 10 squared. And that's 1 over 100. 2 to the negative 4 is the same as 1 over 2 to the 4th. You guys can figure out what that's going to be. That's really hard to see, but that says negative 2 to the 0 power. Remember from the first page, anything raised to the 0 power is 1, except for 0 raised to the 0 power. So if you've got negative 2 raised to the 0 power, it's 1. Okay? A number raised to the negative 1 power. 3 raised to the negative 1 power was 1 over 3. So 56 raised to the negative 1 power is 1 over 56. Okay? 1/3 raised to the negative 2 power. Okay, so this one, if you are careful, follow along with me. Remember, a number raised to the negative power is 1 over that number. So 1 over 1/3 squared. Okay? Well, that would be 1 over 1/3 squared is 1/9. 1 over 1/9. If y'all remember your rules about dividing by fractions way back in the day, when you divide by a fraction, it's the same as taking that fraction, flipping, and multiplying. So 1 divided by 1/9 is the same as 1 times 9 over 1, which is 9. Okay? All right, I think I kind of lied. I'm working all of these with you because I think we'll have plenty of additional practice. This is going to be 3 times 1 over 6 squared, which is 3 times 1 over, what's 6 squared? That's 36. What is 3 times 1 over 36? Well, remember, I can make this look like a fraction too. So 3 times 1 is 3 over 36. And that'll reduce. Those are both divisible by 3. So that's going to reduce to 1/12. Oops. Okay. All right, then you're going to find roots and simplify the expression. All right, remember, when you've got a number raised to a fraction, the denominator of the fraction basically tells you what root you're taking. The numerator of the fraction tells you what you're going to then square everything by. So this says the square root of 81 to the first power. Okay? What is the square root of 81? It's 9. 9 to the first power just means 9 multiplied by, just 9 one time. So that's 9. Okay? 125 to the third power, to the 1/3 power, excuse me. So the denominator, tells you which root to take. So you are taking the third or cube root of 125. The numerator tells you what you are then going to the numerator tells you what you're going to then raise this, what power to raise it to. Okay, so it happens to be that 5 times 5 times 5 is 125. So the cube root of 125 is 5, and 5 raised to the first power is just 5. Okay. 49 to the 1/2 power. So that's going to be the square root of 49. So that's what the denominator tells you. Raised to the first power. This over here is going to be the square root of 4 raised to the first power. Okay, the square root of 49 is 7. 7 to the first power is just 7. The square root of 4 is 2, and it's just 2 raised to the first power. So you wind up just having 7 minus 2, which is 5. Okay? All right, 10. 16 to the 4th power really means take the 4th root of 16 and raise it to the first power. And then add the 1/5. The 5th tells you you're going to take the 5th root of 32. Numerator tells you to raise it to the first power. Okay. The number that you would multiply together 4 times to get 16. What number times what number times what number times what number? What number times itself 4 times is going to give you 16? Well, that's 2. 2 times 2 times 2 times 2 is 16. So the 4th root of 16 is 2. 2 raised to the first power is just 2. What number multiplied by itself 5 times is going to give you 32? So you're asking for the 5th root of 32. Well, 2 times 2 times 2 times 2 times 2 is 32. So the 5th root of 32 is 2. And you're raising it to the first power. So that's just 2. And 2 plus 2 is 4.